And welcome back, code friends and code family. This is St. Raz, and we are here on Cajun Coding, continuing our jaunt through Java on the Codingbat website, courtesy of Nick Parlante. And we have finished up the string, I think string 2. It's string 2, I think. String 2. Rather than go on to string 3, we're going to go to Array2 and catch up there on arrays before going on to string 3. And starting out on the exercises here, our first exercise is count evens. Instructions are return the number of even ints in the given array. Note that the mod operator computes the remainder. That is 5 modulo 2 is 1. And the return type here is, of course, an integer, and it's basically a count. So we're going to go ahead and give it count as the name, and before we start counting, of course, the count is 0. Our reliable for loop here, and just a reminder, no parentheses when you call the length method on an array. You would have empty parentheses there if you for a string. And easy conditional here. So if the element nums address I modulo 2 equals 0, if that's the case, it's even. And we will increment our count variable. And then outside of our for loop, we'll return that count. And off to an easy start there. Our next exercise, Big Diff. Given an array length 1 or more of integers, return the difference between the largest and the smallest values in the array. And then it goes on, built-in math, min, v1, v2, variable 1, variable 2, and max, or methods we can use to return the smaller or larger of two values. So now we are going to need containers for the smallest and the largest values there. And we can go ahead and initialize those to the first element in the array. Obviously, those are going to be the same number at first. Let me see. And we don't actually need a value as a container for the answer, because we can do that in the return statement at the very end. So we're going to return large minus small. And then we're going to use a nice for loop here where the magic will happen. Okay, and let me see, the contents of the rest of the array is irrelevant. All we need to do is find that largest and smallest and return the difference there. So, and we can do that easily with just a couple of if statements here. If nums I, the current element we're looking at, if that is smaller than our small variable, then we're going to replace the current value of the small variable with that element, the value of that element in the array, like so. And it's going to be a very similar process for our large. If it is greater than large, then we can replace large with that value. we didn't even use math min and math max. How's that work? Okay. Well, what we can do there, let me show you how that works. Let me see. Small, we're going to assign to the small variable math min, the smaller of two values, and those two values are going to be the current small and the element nums, the one that we're looking at as the one that we're currently looking at as we iterate through the array there. And that should do it. And it's going to be much the same here. Now you'll notice actually there's really not that much difference between the length of these statements. This one is a little easier to read for the novice, you know, that you can see what's going on there. It's very familiar. This actually uses the min method of the math object, math Java object. You should be familiar with both of those, of course. There are a lot of methods available to the math object that can come in very handy. So, and on to the next one. Centered average. Return the centered average of an array of ints, which we'll say is the mean average of the values, except ignoring the largest and smallest values in the array. If there are multiple copies of the smallest value, ignore just one copy, and likewise for the largest value. Use int division to produce the final average. You may assume that the array is length 3 or more. So now we're going to ignore the largest and smallest values there, so let's go ahead and make some variables. And we can go ahead and set those up as the first, and if that turns out ultimately to be incorrect, our for loop's going to catch that and update that. And we also need a sum. We're going to, and we'll go leave sum at 0. And we're going to sum all the elements in the array before we divide by the number of elements in the array to get the average. And of course use a for loop. Let me see, we're going to go ahead and add our current element to the sum. And let's go ahead and use our, let me see, we don't have to use the if. Let's go ahead and do small assign math min small and nums I, and then large equals math max large and nums I. Make use of those lessons we garnered earlier. And that'll bring us all the way through the array, updating those values as needed, and then we return the sum minus the largest variable, largest element of the array, minus the smallest, and then we divide that sum by the number of elements in the array. But we're going to ignore the largest and smallest, so we're going to subtract 2 from that. And of course, we're going to need some parentheses to control our order of operations, since the natural order of operations is going to give us the wrong answer. Comme ça. That way we're getting this total amount then divided by this total. If we remove those, this actually, let's see, oh no, actually this will be incorrect. mostly incorrect. Some of them are accidentally correct. This will be the smallest divided by the length minus 2, and then that section is going to be subtracted from sum at large. So always be wary of order of operations. Okay, and on to the next one, sum 13. Return the sum of the numbers in the array, returning 0 for an empty array, except number 13 is very unlucky, so it does not count, and the numbers that come immediately after A13 also do not count. And starting with the very simplest things that we know about the solution, we're returning an integer, so it's going to be, you'll call it sum, and we're going to initialize that at 0. Now we do have some possible edge cases. So if num's length is equal to 0, if we just return sum, its sum's already at 0. So else if num's length is equal to 1, let me see, and num's the only element there is not equal to 13, then we return num's 0, which we return the only element in the array. And then otherwise, we're going to use a for loop to iterate through the array. Let me see if, let's do a for. Okay, so we're going to kind of take a look. Now we're not counting 13s, and we're not counting anything that's right after a 13. So as we iterate through the array, we can look at I, wherever I is at the time. And if it's not 13, and if the one previous to it is not 13, then we're going to go ahead and add that to sum. So we could start at I1, but then we might not get the first one very correctly. So what we're going to do instead is use an if statement. If I is equal to 0 and num's I is not equal to 13, then we're going to add that. Now, if I is greater than 0 and num's I is not equal to 13 and num's I minus 1 is not equal to 13, then we add to sum num's I. And when all is said and done here, we return the sum. And there we go. Now notice in this second block here, if num's length equals 1 and num's is not equal to 13, what if it is equal to 13? Well, if it is equal to 13, we only have the 1, then basically this loop is all at 0. You know, this loop basically does it because num's length is 1. So basically there's nothing there. I is equal to 0. Is not 13. So basically what we're doing is we're never adding anything to the sum, which was initialized at 0, so it does come back as 0, since that was its default. Okay. And on to the next one, Sum28. Return the sum of the numbers in the array except ignore sections of numbers starting with a 6 and extending to the next 7. It does tell us every 6 will be followed by at least one 7. So we do know if we have that 6, then we're going to have a 7. We're going to run to 1 eventually. And it says return 0 for no numbers. So go ahead and starting out sum equals 0. If we find no numbers, of course, if we never add anything to that sum, it returns 0, which is correct in that case. Now we have sections of numbers, or we may have sections of numbers that we're going to be ignoring. And a great way to do that is with a Boolean flag. So we use a Boolean, and we'll just call it flag because I'm so creative. We're going to start that flag as true, and we're only going to turn that flag to false when and if we run into a 6. So we're going to start it out as true. And then we've got our for loop. After all the logic in the for loop, we're going to return our sum. Alright, let me see. So we're going to iterate through the arrays. So int I equals 0, I is less than num's length. Okay, so if now if we run into a 6, so if nums I equals 6, if that happens, we're going to set our flag to false. If nums I equals 7, let me see, and we're going to set our flag to true, back to true. And once we've managed our flags a little bit, sum, we're going to add to sum, if flag sum is going to be added to nums I is going to be added to sum. Now what this does is, and remember, if we just have a single item there, this is a Boolean. So if flag is set to true, this is true. If flag is set to false, this is false. So that's all we have to put in there. Now, see, ignore sections. Now, ignore sections of numbers starting with 6 and extending to the next 7. So I don't think we're supposed to include the 7. So what we can do here is we run into that 7, we can set the flag to true, but we don't want to execute this. And this is where I'm going to be introducing a new word. I don't think that we've used this in any of the exercises yet. We've used break. What break does is it breaks us out of that for loop. Now what break does is it breaks us out of the for loop. We don't go here. What we do is we go here at the end of the for loop, and the compiler picks up with the next line here. And we've used break quite a bit. I don't think we've used another word, continue. Continue, very distinct from break. What continue does is that it sends us back here. So the for loop continues running, but it ignores everything below the continue that's within the for loop. Okay, so if we continue, we go back here. That also means that we're going to be iterating the iterator here is going to operate. So if we find a 7, if we continue, we do not execute this, but we go back into the for loop, so we move on to the next index that we were iterating through. So we do that. It is mostly correct. Well, what happened with that one? Let me see. So 2, 7. Oops. Well, one, we have a problem here because we have 2 7s next to each other. So that should be 1, 8, and it only comes up with 1 because we ran into that 7. It doesn't want to count that 7. We don't want to count this 7 because it's right after the 6. This 7 we should count. So we've got a little fine-tuning to do here. If we're into 6, we turn the flag to false. I'm not counting that. Now, if we run to a 7, what we need to do is if we run to a 7 and flag is still true, no, actually a flag is false. If we run to 7 and flag is already false, then we want to flip flag to true and we want to continue and go back into the loop. And then if flag is true and we reach this block of code because we didn't hit the continue here, then we're going to be summing that. And there we go. So now we have, and of course we use the not. We've used the bang before for not. But I think this is the first time we talked about continue. So that's how that works. Array2 has 22. Given an array of ints, return true if the array contains a 2 next to a 2 somewhere. So let me see. It's deceptively simple. This doesn't look very hard. Let me see. So we do a for loop. Now if we find it, we'll return true. So let's return false as our default if we don't find what we're looking for here. And if we do find what we're looking for, then we'll return true. And of course returning is going to break out of the for loop, so we don't have to worry about doing the rest of it there. Seems like there's an obvious edge case here. If nums, actually we could do just one. See, if nums is, if nums length is greater than 1, we're going to do this for. Alright, so for int I equals 0, I is less than nums length, I plus plus, and if nums I equals 2 and nums I minus 1 equals 2, return true. And we're going to start at index 1. There we go. Now a couple things. We're going to start at index 1. So we're always going to have an index to the left of the one we're currently at, because we didn't start all the way to the left of the index. We didn't start with the first element, we started with the second element. So we know that there's going to be an element 0. What if we don't have 2 elements? Well, this if takes care of that. If the length is not greater than 1, then it's not going to run this loop. It's just going to go straight down here. If the length is 1 or less, then we can't possibly have 2 2's, so this default value of false is correct. In that case, if this for finds 2 adjacent 2's, it returns true. If it runs through the entire array and doesn't find it, then it kicks down to the same false here, which is also correct. You might not want too many. It's just as easy to say that if length is less than 2, we could put a return statement right here, return false, but then we've got a return false here and a return false here. We're only returning either true or false, so we really shouldn't have 3 return values in the same function. It's not the worst thing in the world, but could be considered to be kind of bad form. So that's how that works. And on to the next one, Lucky 13. Given an array of ints, return true if the array contains no 1's and no 3's. So, flipping that logic on its head, we want to return false if we find any 1 or any 3. So, what we can do is return true as our default, and we'll return false if we find one of those values that is a spoiler. And if nums I equals 1, or if nums I equals 3, return false. And it should do it. Yeah, there we go. And sometimes it's easier to look for the false, look for what makes something impossible or makes it false, rather than looking for what makes it true. Look for the spoiler, and if you don't find that, return the default value of true. And I think we'll do one more. Given an array of ints, return true if the sum of all the 2's in the array is exactly 8. So we know we're going to be return sum. What we're going to do is we're going to set up our sum. So int sum equals 0 before we start counting, and then we're going to have our iteration through the array. And if nums I equals 2, we're going to add 2 to the sum, and then we're going to return. Now it says this is a Boolean that's returned, so we're not returning the sum, we're returning whether the sum is exactly 8. So return sum equals 8, which is not returning a integer value, it's returning a truth value of the statement sum equals 8. So if sum is equal to 8, it returns true, otherwise it returns false. And I did want to mention that we've got some of the exercises here where we're swapping values around. Let me find one of those. Which one? Okay, yeah, this is one of them where we're changing the value. Say we have a variable small, and then we compare the size of that variable, that value, to another value. Say the element at the address of nums that we're iterating through. Those variables remain the same. The variable remains the same in terms of that small variable. If we end up changing the value in it, the variable small itself is the same, meaning that it is the same memory address. It has the same ID during runtime when the program is executing. Now the value inside that variable may change, but the variable's identity itself does not change. If you want to think of it as being a container, it's the same box, it's the same container. It has the same ID. It has a particular memory address. But the contents could change. And it will change. That's why we call them variables, because they do change. There's a difference between the identity of something containing data and the data itself, the value itself. So if you have any experience, obviously, if you've done some studying and such, you're probably well aware of that. But if you're very new to computer programming, do understand that it's a very important distinction between a value and a variable. There's a difference between the identity of something that's being operated on and the value that it contains. So all right, well, I think we're going to wrap that up this time, and we're going to go ahead and continue on with the next, where are we, Array2. Yeah, we'll get a few more banged out next time. As always, thanks for listening. I appreciate you guys tuning in. Like, subscribe, recommend the channel. Any questions, comments, critiques, or requests are always welcome. Talk to you guys next time. Bye-bye.